I'm Lena.
I'm Justin. And together we are HRS FlowRe.
So here in Figure 1 is a side-by-side model of our in-lab setup of the sedimentation tank and a full-size sedimentation tank in general of our plant. So the sedimentation plates correspond with the tube settler, and the flock blanket is generally found in the recirculator. So HRS's overarching goal has been to increase flow rate, decrease tank size, and lower effective cost for a couple of years. The issue with previous subteams has been that the results we desire at higher flow velocities are often not what we want to see. So we've been working on trying to ameliorate this issue. The nice thing about working with higher flow velocities is that hopefully the sedimentation tank would work more efficiently, and then we can process higher volumes of water and eventually lower effective cost of the plant altogether.
All right, so how does this relate to FlowRe? Well, FlowRe is one of a few proposed solutions to the issues that Lena just mentioned. HRS bottom geometry is looking at another potential issue, or another potential solution rather. The hope is that by installing a recycle line from the top of our recirculator back down to the bottom, that we can increase the residence time of flocks in our system, thereby increasing our flock blanket longevity, as well as our performance at higher upflow velocities. I would recommend looking at this textbook section that Monroe wrote. It goes into a lot more of the theory, so if you want to see some more equations and stuff, this is a wonderful place to go. Yeah, so the first step with this in mind was to actually design a system we could run tests on. So there were two ways we considered going about this. The first was by using PVC glue. The second was by drilling and tapping our set tank. PVC glue was the first thing we tried, but unfortunately it didn't hold up against the pressure in our system, and it also wasn't watertight, so we weren't able to use it. There were two issues we ran into with drilling and tapping our set tank. The first was that due to spatial constraints, we weren't able to drill directly beneath the flock weir, and so it's slightly off-center. And the second is that the tap that we used for the first couple experiments wasn't flush with the inner diameter of the tube settler. And this caused flocks to kind of settle out on top of it, which caused a little bit of an issue. We'll revisit this again in experiment 3.
So here are our initial results with the recycle line. The blue line shows our baseline trial without FlowRe, and our orange line is with FlowRe. So our results were suboptimal and not really what we wanted to see, but they were also not unexpected. But I'll get into that in a second. So throughout the experiment, there was about like a 30 NTU difference between the orange and blue lines, and also this flock length was not any more stable than we had seen in the baseline trial. The reason this isn't necessarily unexpected is because looking at the sedimentation tank, there's really no reason that water should not flow up both the recycle line and the recirculator at the same time. What we had hoped to see was that maybe the density at the top of the flock blanket would push water down through the recycle line and then cause a sort of circular motion to help stabilize the flock blanket. So the next thing we tried was keeping the valve closed to the recycle line for a little while before opening it up. And we hoped to see if maybe this would affect the stability of the flock blanket and maybe that difference in the NTU. What continued to happen was, well, after we opened the valve at around 3 hours in, there is a spike in the turbidity. But then it seems that 30% of the influent still skipped the recirculator and left with the effluent.
Yeah, so with these less than ideal results from the first couple experiments we ran, we decided to revisit the issue of the tap not being flush with the inner diameter of the tube settler. We were worried at first that we would have to spend a lot of time manually sanding down our tap by about like a centimeter just to get it to be flush. But fortunately, we had the forethought to check a few of the other taps that were the same size that were just in the lab. And we were able to find one that must have been just a teeny bit bigger that actually fit our system perfectly. So the results from this experiment genuinely surprised us a lot. As you can see here from this graph, the effluent turbidity of our trial with the tap being flush was almost identical to the effluent turbidity of our baseline trial without FlowRe at all. There are a couple things I'd like to point out about this graph. Again, the valve was closed initially for the first around 5.5 hours of the experiment, You can see here a tiny little spike in effluent turbidity right when we opened it, but it quickly stabilizes out again. And the second thing is that when we came in to open that valve, we observed that at this point, the flock blanket had already collapsed, which was something we had observed in our baseline trial and in all of our trials in previous semesters. So what this signals to us is that the limiting factor for our performance with FlowRe might be the bottom geometry of the sedimentation tank. And that actually plays very nicely into our future work section. So the first thing we recommend that future subteams work on is installing a peristaltic pump to force the direction of flow back down the recycle line. Because although this semester we did achieve a lot of very interesting results that are very valuable for future subteams, we were not able to achieve our goal of getting that cyclical flow. We would hope that the peristaltic pump would force that to be able to happen for a sort of a proof of concept, so that if that does indeed improve our performance, future subteams can then look for a way to do that without using a pump. There is one concern with this though. We are worried that the shear caused by the pump could cause flocks to break up, which would definitely affect results. But the biggest thing we recommend for future subteams is that they continue working with high rate set bottom geometry to try and find a geometry for the entrance to the set tank that will improve performance for FlowRe. Because, like we mentioned, our last experiment implies that this may be the limiting factor. All right, so if you have any questions, comments, complaints, compliments, feel free to reach out to either of us. We'd be happy to speak with you. And with that, thank you guys so much for watching.